Hey there guys, in this episode we are going through Edexcel's June 2018 Higher GCSE Maths Paper 2, which is the first calculator paper. Now I think I remember the reaction to this one, also not being very positive, so I'm going to try and make this as helpful as possible. I'll also put links down below in the description to useful topic playlists and other useful bits and bobs to help with your revision. Let's go. Okay, for question 1 we have some indices fun, so my playlist on that is down below in the description if you need any help. So, A wants us to simplify m cubed times m to the power 4. So when you're multiplying the same numbers or letters like this, you add the powers. So this is m to the 7. Part B wants us to simplify 5np cubed, all cubed. So when powers are separated by a bracket, we multiply them together. Now every term inside the bracket gets affected by this power on the outside. So we can think of 5 as being 5 to the power 1, and then we've also got n to the power 1. So this is going to be 5 cubed n cubed p to the 9, and then we would want 5 cubed as a normal number, so 5 cubed is 125. So we've got 125 n cubed p to the power of 9. Okay, now part C wants us to simplify 32 q to the 9 r to the 4 divided by 4 q to the 3 r. So the trick to one like this is to work through it bit by bit and cancel out common things as we go, common factors I should say. So starting with the normal numbers at the start, 32 can be divided by 4. So we can divide the top and bottom by 4. So first of all we can simplify this to 8 q to the 9 r to the 4. Now on the bottom the 4 has been divided away, so we've now got q cubed times r. So that's the numbers sorted out. The next term we're going to sort out is the q's. So between q to the power 9 and q to the power 3, the highest common factor of q is q to the power 3. So we can divide the top and bottom by q to the power 3. So that's going to give us 8 q to the 6 r to the power 4 all over, while the q to the power 3 has been divided away. So now what we've got on the bottom is an r. So the last thing we need to do now is divide through by that r. So we're going to get 8 q to the 6 r cubed. Good times. 2a wants us to find the lowest common multiple of 40 and 56. So the lowest common multiple means the smallest number that 40 and 56 both go into. So we could write each number as the product of prime factors, use a Venn diagram, find the lowest common multiple that way. If you want to see how to do that, I'll put a link to my prime numbers playlist down below in which that is covered. We can just use a bit of common sense though. We know that 40 only goes into multiples of 10. So anything that 40 goes into is a multiple of 10. So we are going to want then multiples of 56 that are also multiples of 10. For example, if we did 10 times 56, we would get 560. So that is a multiple of 10. So 40 does also go into that. There is a smaller one though. If we half 560, we get 280. Now 40 goes into 280 7 times, so 280 is our guy. Okay, then part B. A is 2 cubed times 3 times 5, and B is 2 squared times 3 times 5 squared. We want to write down the highest common factor of A and B. So to do this, when our numbers are already in product prime form, we go through and we pick out the highest common factor at each stage. So between 2 cubed and 2 squared is the highest common multiple of 2. So we want 2 squared. Now both of them have times 3, so that's common to both. So we want that. And then between 5 and 5 squared, 5 is the highest common multiple of 5. So we put a times 5 on the end. So this is 4 times 3 times 5, which is 60. Don't forget to calculate paper. If it's tricky, make sure you use your calculator. Question 3. The line L is drawn on the grid, and our job is to find the equation of L. So L is a straight line, so we're going to need the general equation of a straight line, which is y equals mx plus c. Now I'll put a link in the description to my equations of straight lines playlist, which contains all of this stuff that we need. So m is the gradient of the straight line, c is the y-intercept. So straight away, our y-intercept, we can see here, is minus 6. So that tells us c is minus 6. So up to here, we can say the equation of our line is mx minus 6. So now we need to find the gradient. So the way I teach gradient is difference in y divided by difference in x. So what we need to do is find two nice coordinate points. So what I mean by that is whole number coordinates, basically. So we got this point here, which has coordinates 2, 0. We could use this point here, 1 minus 3, I'm going to use our y-intercept though. So this guy has coordinates 0, minus 6. So, again, gradient m is the difference in y divided by the difference in x. So, our y coordinate of this top point is 0, and the y coordinate of the bottom point is minus 6. So the difference is 0 minus 6. And then the difference in the x coordinates is 2 minus 0. So because I did 0 minus 6, I have to do 2 minus 0. I can't then do 0 minus 2. So 2 minus 0 on the bottom. Now on top, 0 minus 6 is a double negative, so that gives us positive 6. So we got 6 divided by 2, which is 3. So the equation of our line is 3x minus 6. Question 4, so the first 5 marker, and I believe the first question that nobody really liked. So Raya buys a van for £8,500 plus 20% of that. Raya pays a deposit for the van. She pays the rest of the cost in 12 equal instalments of £531.25p. Each month, we want to find the ratio of the deposit Raya pays to the total of the 12 payments and in the simplest form. So, to be able to do that, we're going to need to work out the deposit that she paid and also the total of the 12 monthly payments. So before we do any of that, we're going to need to work out the total cost of the van. So we could work out 20% of 8,500 and add it on. Remember, you've got your calculator. So the way that I would do this is 8,500 times 1.2. So that is increasing 8,500 by 20%. So that gives us £10,200. So that is the total cost of the van to Raya. The next thing I would work out is the total of the 12 instalments. So the 12 instalments total is 12 times 531.25, £531.25p. Now that gives us £6,375. So that's the total amount of the 12 instalments that she's going to pay. Now we need to work out how much the deposit was. So the deposit it's going to be the difference between the total cost of the van and the total of the 12 instalments. So we're going to do the cost of the van minus the total instalments. So that's going to give us 10,200 minus 6,375, and that gives us 3,825 pounds. Okay, so now we know the deposit and we know the total amount of the 12 instalments. So we can start to put our ratio together now. So the deposit to the instalments is 3,825 to 6,375. Okay, so that is the ratio. It's just now not in its simplest form. So these two are really big numbers. Hopefully it's quite easy to see that they both at least have a common factor of 5. So we could divide both sides by 5, and then we would find that we got to do that again. It's going to take quite a long time. So our calculators can really help us out here. What we want to do is simplify both sides of this ratio. If we were to put these two numbers in as a fraction and press equals, our calculators would simplify them for us in one step. So if you put into your calculators 3,825 divided by 6,375, it's going to take out all the common factors between those two numbers and give us 3 over 5. So our ratio in its simplest form deposit to instalments is 3 to 5. Good times. And 5a wants us to complete the table of values for y equals x squared minus x minus 6. So the first one we need to do here is minus 2. Now be really careful if you're using your calculator to do this. So when x is minus 2, we get y is, now if you're putting it into a calculator, you need to put the minus 2 inside of a bracket here like that. And then with a square on the outside. Then we got minus 2 minus 6. So minus 2 squared is positive 4. Minus 2 is add 2. So we got 4 plus 2 minus 6. That's going to give us 0. Okay, for minus 1, again put the minus 1 inside a bracket, so if you're using your calculator. And then we got minus 1 minus 6. So minus 1 squared is 1. Minus 1 is plus another 1. So that's 2. Minus 6 gives us minus 4. Okay, when x is 1, we get y is 1 squared. We don't need brackets now. because we got positive numbers, -1, -6, which is 1, -1, which is 0, -6 gives us -6. When x is 2, y is 2 squared -2 -6, which is 4 -8. So that's going to give us -4. And then when x is 3, y is 3 squared -3 -6, which is 9 -9, which gives us 0. Okay, so what we're going to want to do now is plot these points on this graph down here. So let's do that. So the first point we want is -3, 6. So find -3, which is completely on the left. Find 6. Our first point is there. Then we want -2, 0. So -2, 0 is this point here. Then we want -1, -4. So -1, -4 is this point here. Then we want 0, -6, which is this point here. And then we want 1, -6. So 1 -6 is this point here. Then we want 2 -4. Just that point there. And then finally we want 3, 0. Which is this point here. So when you're plotting graphs, you've got all your points in. The last thing to do is to join them all together, which is going to go really badly if I try and do it on camera. Our graph should look something like that. Okay, then part C wants us to use our graph to find estimates of the equation, solutions to the equation x squared minus x minus 6 is equal to -2. So the way that we do that, on our graph, we want to find the points where the graph is equal to -2. So we draw a horizontal line across y equals -2. So that will look like this. And what we want are the points of intersection with the line and the graph. So using my graph, I would say this point is roughly -1.5, so that's 1 value of x. And then this guy, it's about 2.6. So the estimates I would get from my graph are -1.5 and 2.6. Yours might be slightly different because your graph will be slightly different, but as long as they're in that sort of area and they fit with your graph, you'll get the marks. Okay, question 6, we're given the formula for pressure, which is force divided by area. Now we're told a force of 17 newtons acts on an area of 20 centimeters squared. The force is increased by 10 newtons, the area is increased by 10 centimetres squared. Alan says the pressure decreases by less than 20%. Is Helen correct? We must show our workings. So, let's work out the pressure at the start. So, we'll call that the initial pressure. Well, that is 70 newtons over 20 centimetres squared. So, 70 newtons over 20 centimetres squared. That simplifies, or as a decimal, is 3.5 newtons per centimetre squared. Then we'll call this the new pressure. Well, the pressure increases, the force increases by 10 newtons and the area increases by 10 centimetres squared. So pressure now is 80 newtons over 30 centimetres squared. So this simplifies to 8/3 newtons per centimetres squared, which, if we wanted as a decimal, we could say is 2.67 newtons per centimetre squared. Now, to work out the decrease, we could divide the new pressure by the initial pressure to work out what percentage the new pressure is of the initial pressure. So, the new pressure, I'm just going to call it new, as a percentage of the initial, well, that's going to be 2.67 divided by 3.5 times 100. And that is going to give us, if we go to the nearest whole percentage, we get 76%. So, if the new pressure is 76% of the initial pressure, then the percentage decrease is 100% minus 76%, which is 24%. So, Alan was saying the pressure decreases by less than 20%. Is she right? No, because the pressure is decreased by 24%. So, no, she is not correct. And we have this shape on the grid, which is a trapezium, and our mission is to enlarge it with a scale factor of 1/3, so it's actually going to get smaller, center 0, 1. So, what this means is, we are enlarging this shape with reference to this point. Now, if the scale factor is 1/3, what that means is each of the corners of the shape are going to be 1/3 of the distance away from the centre of enlargement, and each side of the shape, the new shape, is going to be 1/3 the length of the original. So, if we start with that point there, Now this point is 3 places right and then 3 places up from the centre of enlargement. So we want to go a third of that distance to get this point on our enlarged shape. So 1/3 of 3 is 1. So we're going to go 1 place to the right and then 1 place up. So that point is going to be enlarged to that green cross. Now when we got our first point in, we can sort of cheat a little bit. We know we are enlarging with a scale factor of 1/3. So each of the side lengths are going to be 1/3 the length of the original. So the height of the original is 6. 1/3 of 6 is 2. So the height of the new shape is going to be 2. So we know the next corner is going to be that. Then the top length is 3 long. So on the new shape, that's going to be 1 long. So that's going to be there. And then the side on the right goes down by 3. So we're going to go down by 1. And there is our enlarged shape. In the real thing, use a ruler. Question 8. So 60 people were asked if they prefer to go on holiday in Britain, Spain or Italy. 38 of the people were male. 11 of the 32 people who said Britain were female. 8 males said Italy. 12 people said Spain. We're told one of the females is chosen at random. We want to work out the probability that that person said Spain. So this really is a job for a frequency tree. So we know there are 60 people in total. We then know there are 38 males, which means there are 60 minus 38 females, which is 22. Okay. So, we got Britain, Spain, and Italy, and then the same down here. Britain, Spain, and Italy. Okay, so let's read through the info, see what we can fill in. So 38 of the people were males. We've dealt with that. 11 of the 32 people who said Britain were female. So that's telling us 2 things. 11 females said Britain. 32 people said Britain altogether. So 21 males must have said Britain. Okay, next we are told 8 males said Italy. So let's plonk an 8 there. Now from that we are able to work out how many males said Spain, because we know there are 38 males altogether. So at the moment 21 add 8 is 29. So 38 take away 29 tells us 9 males chose Spain. So we are told 12 people said Spain altogether. So 9 males said Spain, so 3 females must have said Spain. Now we could, if we wanted to, work out how many said Italy. At the moment we got 11 and 3, which is 14. So to make it up to 22, 8 must have said Italy. So remember the question says a female is chosen at random. We want the probability that they chose Spain. So there are 22 females, 3 of them said Spain. So the probability is 3 out of 22. Okay, question 9. Jean invests £12,500 in an account paying compound interest for 2 years. For the first year, the rate of interest is X%. At the end of the first year, her investment is worth £12,336. In the second year, the account pays X over 2% interest. We need to work out the value of Jean's investment after the 2 years. So, let's think about what's going on in the first year, first of all. So in the first year, now we're going to think about this in terms of decimal multipliers. So we know, hopefully if we're happy with compound interest, if not, my percentage increase and decrease playlist is down below, which contains this sort of stuff. So if we knew the percentage amount, we would multiply £12,000 by some decimal multiplier, which here I'm going to call y. So y would be 1 point something, the decimal equivalent of the percentage. Now we know that gives us 12,336. So we can work out what y is. At the moment, 12,000 is multiplying the y. So if we divide 12,000 away, we'll get y on its own. So y is 12,336 divided by 12,000. Now that gives us 1.028. So if we multiply a number by 1, we are just finding 100% of that number. The part that increases the number is what's after the decimal. So we now want to turn 0.028 into a percentage, and that will tell us what x is. So x is 0.028 times 100. So x is 2.8. So the percentage interest that she got paid in the first year is 2.8%. Now in the second year we get paid x over 2%. So x over 2% is half of 2.8. So 1.4. So to work out how much money we have after the second year, we multiply the amount after 1 year by the decimal multiplier for 1.4%. Now, 1.4%, just go down here separately, 1.4% as a decimal divided by 100 gives us 0.014. So to increase 12,336 by 1.4%, we multiply it by 1.014, and that gives us £12,508.70. So there's our answer. Good times. And 10, so we got vector A and vector B drawn on the grid. So before we get started, I'm just going to take you over what both of these would be as a column vector. So vector A, well, it takes us one place to the right, so that's a positive one, and then it takes us 2 places up. So vector A as a column vector is 1, 2. And vector B, well, again, it takes us one place to the right, so it's 1 on top, and then it takes us 3 places down, so it's 1 minus 3, like that. Okay, so part A asks us to, on the grid, draw and label vector minus 2a. So let's work out what that is as a column vector first. So minus 2a is going to be negative of each of the numbers multiplied by 2. So it's going to be minus 2 on top for our x vector and minus 4 for the y vector. So we need a vector that takes us 2 places left and 4 places down. So, for example, we could go from this point down to that point. Make sure you put an arrow on the vector so you know which way you're going. That is vector minus 2a. So it takes us 2 places left and 4 places down. Cool. Okay, then part B wants us to work out A plus 2B as a column vector. So we know vector A is 1, 2. Then we want 2 lots of vector B, which we know is 1 minus 3. So this is 1, 2, and now the numbers inside the vector just get multiplied by the 2. So 2 times 1 on a good day is 2. 2 times minus 3 is minus 6. So we then just add the corresponding parts of the vectors. So the top number is 1 plus 2, which is 3, and the bottom number is 2 and minus 6, which is minus 4. I'll put my column vector video down below if you need any more help with these type of problems. In 11 we got some functions fun, so I'll put my functions playlist down below. Lots of stuff on these. So f of x is 2 over x squared, and g of x is 4x cubed. Part A wants us to find f of minus 5. So all that means is where there's an x, it becomes minus 5. So this is 2 over, again be careful with your negatives, x is being squared, so minus 5 is being squared. minus 5 squared is positive 25. So this is 2 over 25. Part B wants us to find fg of 1. So what this means is f of the value of g of 1. So we need to find g of 1 first of all. So g of 1 is 4 times 1 cubed, which is 4. So f g of 1 is f of 4, which is going to be 2 over 4 squared, which is 2 over 16, which gives us 1/8. So that last one there is a composite function. Got a video explaining those all the way through and in far more detail. Check it out. Question 12, we got these 4 graphs here. Each one represent a different type of proportionality. We want to match the graph to the proportion in the table. So the first one, y is proportional to x. Okay, so this is going to be completely linear. X isn't being squared, it's not on the bottom of a fraction, so it's going to be a straight line going up from the origin with a positive gradient. So this is going to be graph B. So as we go along the x-axis, so as x gets bigger, we can see the value of y also gets bigger too. So the first one is B. Next one, y is proportional to x squared. So as x squared gets bigger, y gets bigger. So let's see if we can track this one down. So what's going to happen as x gets bigger, x squared gets really big really quickly. So the rate at which y increases is going to speed up. So with this top left one here, it's starting to slow down. So it can't be that one. This bottom left one, we can see as x is getting bigger, y is getting smaller, or as x is getting smaller, y is getting bigger. So it can't be that one. Must be this guy then, which it is. So we can see with this guy that as x increases, the graph gets steeper and steeper, faster and faster. So it's D. For that one, then we got y is proportional to the square root of x. So as x gets bigger, the square root of x will always get bigger, but it's going to slow down. So it's like the complete opposite of x squared. X squared gets bigger, faster and faster. Root x gets bigger, but slower and slower. Think about this, say we square root 100, we get 10. Say we square root 144, then we only get 12. So that's not that much bigger. So it's graph A. And then the final one, well, we know which it is by process of elimination. But we'll talk about it too. So y is proportional to 1 over x. This means y and x are inversely proportional. So as x gets bigger, if we zoom in on this bit, x gets bigger this way, we can see the curve gets closer and closer to 0. So as x gets bigger, y gets smaller. As x gets smaller though, so closer and closer to 0, we can see that y gets bigger and bigger and bigger. So that is inverse proportion in all its glory. It's graph C. Question 13, so we got a nice circle theorem problem here. So we got these two angles inside this circle, y and x. Now we are told A, B, C and D are points on the circumference of a circle, centre O. E, D, F is a tangent to the circle. We want to show that y minus x is 90, giving reasons for each step of our answer. So, what can we do? Well, first thing we can do is we actually can say what angle C is. This whole shape A, B, C, D is a cyclic quadrilateral. Opposite angles in a cyclic quadrilateral add to 180. So if that bottom angle is y, and this angle at C is 180 minus y. So I'm going to put a little 1 there, and I'm going to say the reason opposite angles in cyclic quadrilaterals sum to 180. Okay, how does that help? Well, if we now go to the centre, we know this line here, OD, is a radius of the circle. We could create another radius of the circle from B to O, like that. Now we know that this red line and this line are the same length because they are both a radius of this circle. So that means this is an isosceles triangle. So we know this is angle X as well. So now what we can do is work out what to call this angle in the centre. So if we can do that, I'm going to explain. Put a little 2. So notice what we've got here now is an arrow head. Now the circle theorem here is that the angle on the circumference is half the angle of the centre. So, if the angle of the circumference is 180 minus y, this blue angle in the centre is 2 times that. So 360 minus 2y. Now we know angles in a triangle add up to 180. So we now know that 2x add 360 minus 2y is equal to 180. So 2x add 360 minus 2y. So again, what I'm doing there is adding those three angles together. We know that is 180. So if we take the 360 away, we get 2x minus 2y is equal to minus 180. We can divide through by 2, which will give us x minus y is equal to minus 90. So this is the complete opposite of what we want. We want to show y minus x is positive 90. We're not wrong, we just need to rearrange a bit. So if we add the y and subtract the x, we will get 0 is equal to minus 90 plus y minus x, and then if we add the 90, we get 90 is equal to y minus x, as we wanted to show. Okay, then part B says, Dylan was asked to give possible values of x and y. He said y could be 200 and x can be 110, because 200 minus 110 is equal to 90. Is Dylan correct? We must give a reason for our answer. So let's think about this. Remember, we got a triangle in the middle of the circle here with two angles of x degrees. So if x was 110, 2x would be 220, which is greater than 180 degrees. So no, he isn't. Cool. Okay, question 14. So the distance time graph shows information about part of a car journey. So for now, ignore that purple line. There's our distance time graph, distance up the side, time along the bottom. Now we are asked to use the graph to estimate the speed of the car at 5 seconds into the journey. So speed is a rate of change of distance over time. When we're talking rate of change with graphs, we're thinking gradient. So the trick to a question like this is to first of all draw a tangent to the curve at the point we are interested in. So that is what my purple line is doing here. The purple line is a tangent to the curve at 5 seconds. Now what we want to do is find the gradient of the tangent. The gradient of the tangent is going to be the same as the gradient of the curve at the point that it touches. So gradient is difference in y over difference in x. So we need to find two nice coordinate points. So we know we hit the curve at 5 seconds, and I would say the y coordinate of that would be 2 little squares above 20. We can see 5 little squares is worth 20, so 1 little square is worth 4. So the y coordinate there is 28. Now there's another nice one down here we could use. We're only estimating, so I think we get away with saying this point down here is 3, 0. So, to then find our gradient, we do 24 minus 0 over 5 minus 3, which is 24 over 2, which gives us 12. So that is the gradient of the tangent, so it's the gradient of the curve, which means it's the estimate for our speed. So our speed is 12 meters per second. Cool. Question 15. A darts team is going to play a match on Saturday and on Sunday. The probability that they will win on Saturday is 0.45. If they win on Saturday, then the probability that they will win on Sunday is 0.67. If they do not win on Saturday, the probability that they will win on Sunday is 0.35. Part A wants us to complete the tree diagram. So, on Saturday, if they win, the probability is 0.45. Remember, probability has to add up to 1. So to work out the probability of not winning, we do 1 minus 0.45. And that gives us 0.55. Okay, now on Sunday, we have to be very careful here. The probabilities are dependent on what happens on Saturday. So if they win on Saturday, the probabilities are different to if they do not win on Saturday. So, if they win on Saturday, the probability they will win on Sunday is 0.67. So the probability that they do not win would be 1 minus 0.67, which is 0.33. If they do not win on Saturday, then the probability that they will win on Sunday is 0.35. So 0.35 goes there, and then the probability that they do not win is 1 minus 0.35, which is 0.65. So that is our completed tree diagram. Part B asks us to find the probability that the team will win exactly one of the two matches. So with questions like this, we have to be very careful with the language. So we want them to win exactly one match. So there are two possible ways that they can do this. They can win on Saturday and then lose on Sunday, or they could lose on Saturday and then win on Sunday. So, the two paths that we're interested in on the tree diagram are win and then lose and lose and then win. So when you are going along branches of a tree diagram, we multiply the probabilities together. So this first one is going to be 0.45 times 0.33, and this second one is going to be 0.55 times 0.35. Okay, so when we have two probabilities of two different roots, we now add them together. So whatever 0.45 times 0.35 is, 0.33, we're going to add that to the second one, 0.55 times 0.35. So whack that in your calculators and we should get 0.341. Cool. Question 16. So on the grid, draw the graph of x squared plus y squared is equal to 12.25. So I imagine this is one that caused problems. This is actually the equation of a circle centered at the origin. So a circle centered zero, zero, so at the origin, has equation x squared plus y squared is equal to the radius of the circle squared. So we've certainly got a circle centered at the origin. Now r squared is 12.25. So if we square root that, we get the radius is 3.5. So we need to draw a circle with a centre at 0, 0, going through 3.5 or minus 3.5 on all of the axes. So they've even given us a stupid scale. So we go from 2 to 4, so 3 would be there. So 3.5 is the red cross. And that's the same on each of the axes. I'll also link my equation of circle stuff down below. Okay, so we want the circle to cross through the axes on each of the crosses. So we're going to get a circle like this. Okay, so the easiest way for you guys to do that would be to use your compass, put the point on 0, 0, put your pencil on one of the 3.5s, and then draw the circle. Okay, then part B wants us to use the graph to estimate the solutions of the simultaneous equations x squared plus y squared equals 12.25 and 2x plus y is equal to 1. So 2x plus y equals 1 is the equation of a straight line, but we're going to want to rearrange it into y equals mx plus c first of all, and then we're going to want to plot it. So taking away the 2x, we get y is equal to minus 2x plus 1. So the easiest way to plot a graph like this is to find where it crosses both the y and x axes. So remember, in the equation of a line, the number at the end, so here the plus 1, is the y-intercept. So we know a straight line crosses through the point 0, 1. So that's that point there. Now let's find where it crosses the x-axis. So the x-axis is the line y equals 0. So when y is equal to 0, minus 2x plus 1 is equal to 0. So if we add 2x, we can get 2x is equal to 1, so x is equal to 1/2. So it crosses the x-axis at 1/2, 0. So that is going to be, this point here is 1, so 1/2 is going to be there. So now we can draw our straight line, and what we are interested in are the 2 points where it hits the circle. So let's see how this goes, doing it live. Okay, that looks pretty good. So what we now want are the coordinate points of intersection between the line and the circle. So this top guy up here, I think we could say x is about -1, and y is coming down to, I think we could say 3.4, 3.3. So let's go 3.4. So there is our first set of x and y. X is equal to -1 and y is equal to 3.4. And then the other one that we want is down at the bottom, down here. So at this point, x is about 2, and the y coordinate, it's just above -3, so I can say it's -2.9. So you guys might get slightly different answers. It all depends on how accurately our circles and straight lines are drawn. As long as we get answers in these regions, then we're happy as Larry. So, second set of solutions is x equals 2 and y equals -2.9. Good times. Okay, question 17, we got a histogram, so I'm going to put my histogram stuff down below. This one shows information about the time taken by some people to complete a puzzle. Good times. So the histogram is complete. We are asked, first of all, to complete the frequency table. So, in a histogram, I'm going to pick this last bar here. The area of each bar is the interval at the bottom times frequency density at the side. Now this represents the area of each bar represents the frequency inside of that interval. So, for this second interval, 5 to 15, the interval width is 10. So now we need the frequency density, which is 4. So 10 times 0.4 is 4. In the next interval, the interval size is 10 again. So we need the frequency density, which is 0.6. So 10 times 0.6 is 6. The next interval is 5 wide. So for that one, we're doing 5 times 1, which is 5. And then the last one has an interval width of 20. So we're doing 20 times 0.2, which is 4 again. So there's that. Okay, then part B wants us to find an estimate for the lower quartile of the times taken. So the lower quartile is the 25th percent value. So if we add up all of our frequencies in the table, so 4, 4, 6, 5 and 4, we get 23. So the total frequency is 23. Now, if we wanted to find the median value here, we would add 1 to our frequency because it's odd, and then divide by 2. So, the same is true for trying to find the lower quartile. We're going to add 1 and divide it by 4 because we want the 25th percent value, not the 50th percent value. So 23 add 1 is 24. 24 divided by 4 is 6. So we want to work out roughly where the 6th person would be in terms of the time. So if we go back to the table, well, starting from the beginning, there are 4 people in that first interval. So it's not going to mean there. There are another 4 people in the next interval. In the second interval, we know these people took more than 5 minutes, but less than or equal to 15 minutes. So, how we can think of this is, if we don't know about the 4 that we had there, and then we put this interval on a line and divide it by 4. So, we know we're greater than 5 minutes. We're not allowed to do that. We're not allowed to be 5 minutes in this interval. They are allowed to be 15 minutes. So there are 4 people in this interval. So if we divide this interval by 4, we get 2.5. So we could split this interval, or the people in it, in 2.5 minute chunks. So we could say the first person in this interval, which was the 5th person overall, took 7.5. 6th person overall, second person in this interval, took 10 minutes. That would be the one that we're interested in. 7th person overall, 12.5 minutes. And then the 8th person overall was 15 minutes. So using that, we're going to say the estimate for the lower quartile was 10 minutes. Now remember, this is only estimating because we don't actually know anything about the actual times of any of the people. We only know the interval that they fall into. So it is strictly an estimate. 18, brace yourselves because we got some 3D trigonometry. So, we got this cuboid. We are told that AB is 7.3 centimeters. So I'm going to label this as we go. So AB is 7.3 centimeters. That also tells us, because it's a cuboid, DC is 7.3 centimeters. So I'm going to put that length there instead. CH is 8.1. So that gives us the height of the cuboid. We're told angle BCA is 48. Now that's a bit of a hard one to label because it's the angle that we get when we go from B to C to A. So let's have a go anyway. So what that's doing is it's telling us what this angle here is. So it's 48. So that's an angle completely on the base of the shape. We want to find the size of the angle between AH and the plane ABCD. So the plane ABCD just means the base of the shape. AH is this 3D diagonal line connecting A to H. Now the angle then that we want is this angle here. So I'm going to call it theta. So let's take these shapes out of this 3D shape and make everything 2D. So let's first of all draw the thing that we want. So we got this line AH. Now the base, well basically what we can do is we can turn this into a right angle triangle problem. So the base to the hypotenuse, if we call AH the hypotenuse, is the blue line going along the base of the cuboid. So we then got this blue line, and then we've also got the height of the cuboid, which we know is 8.1 centimeters. Now the angle that we want is this chap here. So what would be really handy is if we either knew the red length or the blue length. Can we work either one of those out? Well, let's make a top-down drawing of the base as well. Remember, on the base we've got a length and an angle. So on the base we draw it like this. Okay, so if we're looking down at the base, let's call this A, this B, this C, and this D. Now this blue line is a diagonal between A and C. And we know that the angle BCA is 48. degrees. Now we also know the length AB is 7.3 centimeters. So we can actually work out the length of the blue a line using trigonometry. So, using trigonometry, the blue line is the hypotenuse, 7.3 is the opposite to the 48-degree angle. So, we got the opposite and the hypotenuse. So we're using so sine. So we then know sine 48 is the opposite, so 7.3 divided by the hypotenuse. If we multiply through by h sine 48 is 7.3, and then divide by sine 48, we get h is 7.3 divided by sine 48. Plug that into your calculator and we get, if we go to 2 decimal places, 9.82 centimetres. So what that's now worked us out is the length of the blue line, which is the diagonal and the base. More importantly, it's another length in this triangle. So we now know this length down here is 9.82 centimetres. So now in this triangle we have two lengths. We can now work out this angle. So we're using SOHCAHTOA again. We got the opposite and the adjacent. So sine of theta, no, sorry, it's not sine at all, what am I about? So we got the opposite and the adjacent, so it's TOA, which is tan. So tan theta is the opposite, so 8.1 over the adjacent, 9.82. So to get theta out of that, theta is the inverse tan of 8.1 over 9.82. So on your calculator, press shift and then tan of that fraction, and we get a 1 decimal place as they want it, 39.5 degrees. Good times. Number 19, a monster of a question. So we got the shape S, which is a quarter of a solid sphere. We're given the formulas here for the surface area of a sphere, 4 pi r squared, and the volume, 4/3 pi r cubed. We are told the volume of shape S is 576 pi centimeters cubed. Our mission is to find the surface area of S to 3 significant figures. So, with a question like this, where do you begin? Well, we know the volume of shape S, so that's probably going to be important. Shape S is a quarter of a sphere. What we're going to need to work out here is the radius of the sphere. So, the first thing we're going to need to work out is to work out what the volume of the whole sphere would be. Remember, S is a quarter of a sphere. So, the volume of the whole sphere because S is a quarter of a sphere, we're going to multiply its volume by 4. So it's 4 times 576 pi Now that gives us 2,304 pi. So if we had 4 lots of S, that would be the volume. Now, that's the volume then of a whole sphere. So what we can now say is that 4/3 pi r cubed is equal to 2,304 pi. So we now have a formula that's going to allow us to work out the radius of S. So both sides have a pi, so we can divide both sides by pi. So that gives us 4/3 r cubed is 2,304. So we want to try and get r cubed on its own. 4/3 r cubed is saying 4r cubed divided by 3. So if we now multiply both sides by 3, we get 4r cubed is equal to 6,912. We then want to divide by 4. That's going to give us r cubed is equal to 1,728. And then finally, cube root both sides. R is the cube root of 1,728, which actually gives us a nice value for R. It's 12. So up to there we now know the radius of S. That's probably the trickiest part of this question done. So now we can find the surface area of this shape. So there are 3 faces that we need to find the area of. The first 2, so this one and this one, well, they are both semicircles. So we've got this semicircle and this semicircle. So these are identical semicircles with a radius of 12. So those 2 areas together are going to be the area of a circle with a radius of 12 centimeters. So the area of a circle is pi times the radius squared. So here we got pi times 12 squared, which gives us 144 pi. So we'll turn that to a decimal in a minute when we need to. Okay, the third face is the curved outer part. Which is this bit here. Now that is going to be 1/4 the surface area of the whole sphere, because S is 1/4 of a sphere. Now we know surface area of a sphere is 4 pi r squared. So the area of this curved part. So the curved face of S, well, it's going to be 1/4 times 4 times 12 squared pi. So that's going to be 1/4 times 4 is 1. So for that we get 144 pi again. So the total surface area is the area of the two semicircles add this curved face on the outside. So the surface area is 2 lots of 144 pi. So it's 288 pi centimetres squared. That's the exact answer. But they want it to 3 significant figures. Smash that in your calculator. And we get 904.778 blah blah blah. The third significant figure there is the 4, which has a 7 after it, so it's going to round up to 905 centimetres squared. Lovely. 20 is a little bit nicer, so Martin did this question, rationalise the denominator of 14 over 2 plus root 3. So we've got his method, and we're told his answer is wrong, and we need to find the mistake. So, let's go through it. The denominator is 2 plus root 3, so to rationalise it, we multiply by 2 minus root 3 on the top and bottom. So that's what he's done. So, he's all good up to there. He's multiplied the top, so 14 times 2 is 28. 14 times minus root 3 is minus 14 root 3. So that's right. On the bottom, he's expanded the brackets. 2 times 2 is 4. And then he's got 2 lots of root 3 and minus 2 lots of root 3. But at the end, he's got this plus root 3 there. So the answer, that's where he's gone wrong. He's done positive root 3 times minus root 3, and he's got positive root 3. So that is where he's gone wrong. He's done, what is that? He's done positive root 3 times minus root 3 is equal to positive 3, which is wrong. It would be minus 3. Okay, and then the second part, Sean did this question, so rationalise the denominator of 5 over root 12. Same thing again. She's gone wrong. We want to find her mistake. So, this time we've only got a single third term, so we multiply the top and bottom by that third, which is what she's done first of all, so that's alright. Then up on top, she's gone from having 5 root 12 to 5 times 3 root 2, and that isn't right. So what she should have done is root 12 is root 4 root 3, which is 2 root 3. So she's got it the wrong way around. So her mistake is root 12 is equal to 3 root 2. So that's her mistake. So I guess we'll just say again which is wrong. Cool. The grand finale, and it's a horrible bounds question. I hate this stuff. It just takes so long to do. So Jackson is trying to measure the density in grams per centimetre cubed of a block of wood. The block of wood is in the shape of a cuboid. He measures the length as 13.2 centimetres to the nearest millimetre, the width is 16 to the nearest millimetre, 16 centimetres to the nearest millimetre, and the height as 21.7 centimetres to the nearest millimetre. He measures the mass as 1,970 grams, correct to the nearest 5 grams. By considering bounds, we want to work out the density. Giving our answer to a suitable degree of accuracy, we must show all of our working and then give a reason for our final answer. So the first thing we need is the formula for density. Now this is usually given to you, but it's hidden in the question. So up here, we want the density in grams per centimetre cubed. Grams is a measure of mass. Centimetre cubed is a measure of volume. So density is mass divided by volume. So here, all of our measurements are rounded to, well, all the lengths of the wood are rounded to the nearest millimetre, and the mass is rounded to the nearest 5 grams. So what we are going to want is to find the upper and lower bounds of the density. So the upper bound of the density, well, let's think about this. We want to divide the biggest number possible by the smallest number possible. So that's going to be the upper bound of the mass divided by the lower bound of the volume. And the lower bound of the density is going to be the other way around, so it's going to be the smallest possible mass divided by the biggest possible volume. So that's going to be mass lower divided by volume upper. So we now need to work out what the upper and lower bounds are of the mass and the density. So, sorry, not the density, the mass and the volume. So we'll do the volume first. So let's first of all go for the lower bound of the volume. So when we're wanting the lower bound, we want the smallest possible measurements that would round up to the ones that we have to 1 decimal place. So the smallest number that would round up to 13.2 is 13.15. Remember, the volume of a cuboid is length times width times height. So we're going to multiply that by, well, the smallest number that would round up to 16 to 1 decimal place is 15.95. And then we're going to multiply that by Well, the smallest number that would round to 21.7 is 21.65. Okay, so that gives us, if you stick that in your calculator, that's going to give us 4,540.9. So 4,540.9, and that is centimetres cubed. So that's our lower bound of the volume, the smallest possible thing it could be. Now we need to work out the upper bound. So when we're talking upper bounds, we want the smallest numbers that wouldn't round down to the lengths that we have to one decimal place. So with 13.2, our upper bound is going to be 13.25. With 16, it's going to be 16.05. And then with 21.7, it's going to be 21.75. So, if we multiply those together, we get our upper bound to be 4,625.4. So 4,625.4, and again that's centimetres cubed. So we now have our upper and lower bound of the volume. We now need to find the upper and lower bound of the mass. So the mass is a lot easier. The mass is rounded to 1,970 grams to the nearest 5 grams. So here, the lower bound of the mass is going to be the smallest number that rounds to 1,970 to the nearest 5. So that is 1,967.5 grams, and then the upper bound is the first number that wouldn't round down to 1,970 to the nearest 5, and that is 1,972.5 grams. So now we have our upper and lower bounds of the volume and mass. We can now work out the bounds to the density. So, the lower bound to the density is the smallest possible mass, so 1,967.5 grams divided by the biggest or upper bound of the volume, so 4,625.4. Okay, so I'll work that out in a moment. The upper bound of the density is the upper bound of the mass, so 1,972.5 divided by the smallest possible volume, so that's divided by 4,540.9. centimetres cubed. So, I'm going to work out both of these now. Okay, so we get a lower bound of 0.42536 blah 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 grams centimetre cubed, and we get an upper bound of 0.434385 blah 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 grams per centimetre cubed. Now these two bounds are incredibly close to each other, and in fact, if we round both to 2 decimal places, then they both round to 0.43. So, to 2 decimal places, both bounds round to 0.43 grams per centimetre cubed. So remember, the question is said to give a reason for our final answer. So, the density is 0.43 grams per centimetre cubed. Oh, horrible question to finish on, but we have finished. Hope you found this paper helpful, guys. Don't forget to give us a thumbs up, get subscribed, share these with your friends, trying to help as many people as possible, so please help me do that. Hope to see you in paper 3. Good luck with your exams, take it easy, take care.